Hello everyone, welcome to our video. My name is Iqbal and we are from Group 5 from Biomedical Engineering Department. We would like to talk about the electromagnetic field theory in medical device, which is capnography. In this video, we will explain about the Maxwell equation and Beer-Lambert's law in capnography. So, our objective is to understand the application of electromagnetic field theory in capnography, thus to demonstrate the working principle of capnography device, and we also want to understand the EMT theory and concept in capnography. Okay, so what is the capnography? Capnography is a device that used to measure the carbon dioxide in human breath. It uses infrared electromagnetic waves where the carbon dioxide absorbs specific infrared light wavelengths. This device will detect the absorbed signal to determine the carbon dioxide level and monitor a patient's breathing condition.
Next is a capnography function. A capnograph functions by measuring the concentration of carbon dioxide (CO2) in a patient's exhaled breath over time, utilizing the physical principle of infrared spectroscopy. Because CO2 molecules naturally absorb a specific wavelength of infrared light that is 4.26 microamp, the device can determine exactly how much gas is present based on how much light is blocked. So this is the core working principle for capnography. The first one is light emission. An internal infrared lamp shines light through a chamber containing the patient's exhaled breath. Number 2 is the light absorption. So as the breath passes through, the CO2 molecules absorb a portion of that infrared light. So number 3 is detection. A sensor on the opposite side will measure the remaining light. So for the calculation, number 4, the monitor applies the Beer-Lambert law. So more CO2 in the breath means less light reaches the sensor. And the last one is graphing. The computer will translate these measurements into a real-time waveform that is a capnogram and outputs a numerical value for entitled CO2.
For the project demonstration, we do a simple capnography-related experiment using a TV remote, battery, and A4 paper. The battery supplies electrical energy to the remote, and when a button is pressed, and the remote emits infrared IR electromagnetic wave. The smartphone camera acts as a detector to observe the IR light, which is appear as a blinking purple light even though it's invisible to the human eyes. The A4 paper is used as a background and also as a shield during a breathing test. When breath passes through the opening towards the remote, the brightness of the IR light decreases slightly due to the absorption and scattering effect caused by the moisture and carbon dioxide in the breath. This experiment related to capnography because the capnograph also used infrared light to detect the carbon dioxide in human breath through IR absorption principle. In conclusion, this demonstration shows the basic concept of the infrared detection and the working principle used in the capnography.
So next, I'm Ms. Rina Batrisha and I will explain about EMT concept and theory part. For our project, we are applied using Maxwell equation and Beer-Lambert law for our projects. That means, Maxwell equations explain the generation and propagation of infrared electromagnetic waves used in capnography. Beer-Lambert law explains how carbon dioxide absorbs IR light, causing an exponential decrease in intensity, which means measured and converted into a carbon dioxide waveform.
Hi, I'm Nur Fatin Farzana and I will be explaining about the biomedical application for our capnography. For capnography, the carbon dioxide molecule will absorb the specific wavelength of infrared radiation, which is 4.26 micrometer. The capnography will measure the concentration of carbon dioxide in a patient's exhale breath. So the system will monitor the respiratory health based on the level of infrared attenuation. For the similarity to the experiment that we just did, the clear air and the exhale breath represent the different level of molecular charge density. So the higher the carbon dioxide concentration, the higher the infrared absorption. So the similar principle used in the hospital grade monitor to track the ventilation in a real time. By measuring the attenuation, the doctor can non-invasively track the respiratory health without needing a blood test. In conclusion, the exhaled breaths show a higher infrared attenuation than a normal air due to the presence of carbon dioxide molecule. The molecular charge distribution of carbon dioxide interact with the electric flux that will affecting the electromagnetic wave propagation. The experiment successfully demonstrated a fundamental ENT concept using Maxwell's first law and the Beer-Lambert law. Principle of exponential wave decay and the infrared absorption are used in capnography to provide a non-invasive monitoring of patient health.